Alright, we got no script, but yo, I'm right. And so let's see, about 3 months ago, about 3 months ago, I finished algebra 2 in my high school. Yeah, I can spell algebra 2. Finished that in my high school, and it turns out I actually like math. Turns out I actually like math a lot more than I thought. I thought math was pretty alright. I thought I was an alright guy, but you know, I just wasn't that into it. But I don't know what happened. I'm not sure it clicked, but I'm pretty into it now. So, yeah. What I've been learning on my own is like very basic like derivative stuff. Like you got your power rule. Oh wow, you can draw the spacebar. You can do like power rule and stuff like so like that go bam because you drop down the 2 minus the 1, you get that crazy. uh, and like that's the derivative. That's crazy. I don't really know what that means still. I think it means continuous, like a continuous change on the graph x squared, which you know what, I'll just draw that graph here, x squared. Shabam, amazing. And that was like really cool. I don't know why. And then I started, looking at other things. So we looked at logarithms in my school and all that, but we didn't really like look at them too much or whatever that equals at whatever. We didn't really learn logarithms too much, so I've dabbled in a little bit with those. I forgot what they're called. Let me think. Okay, so I think they're called I have my sketchbook of math here. It's like I think I have like 20 pages of just pure math. It's supposed to be like a sketchbook where you draw inside of it, but nah, it's math now. So yeah, like one of the first things I learned, oh yeah, like my big inspirations are like black pen, red pen. Is that it? Pretty sure. Blue pen, red pen. Big inspiration for me. He's very cool. He just seems like a chill guy. But yeah, like stuff like this, where you just solve for each side and use like natural logs and everything. Pretty cool, right? Pretty cool. So I would absolutely say yes, I am like very amateur math guy. I am amateur math guy at its finest and all that. But I just think it's cool. I think it's cool and I think it's fun. Like, oh yeah, like of course before learning the derivatives and whatever, that's just a graph. I don't know why I'm circling that. But yeah, before learning that, I learned the difference quotient and whatever. I was like, oh dude, that's so sick. I don't know why this is sick, but I think it's sick. And like I didn't even know what this means, which like I still kind of don't now. I mean, I know it's like, hey, you got a line, then you got a dot, and then you're like trying to get like super close to it, but you're not like actually on that dot right there. So like, yeah, that's like, I know that's what a limit is, like, blah, yeah. And so yeah, the purpose of this channel is just for me to like, see how far I've come, because I look at the sketchbook I have right here. I don't know if you can hear it, but I'm flipping it right now. But just see how far I've gotten, cause yeah, I've made pretty decent amount of progress, honestly. Like probably the latest thing I've been doing right now is hold on, let's get rid of this x squared graph. Let's get this guy out of here. Boom, he's gone. Like what I'm kind of learning right now is the unit circle. So you got like your bam, radius equals 1, and we'll just like go halfway, and it's like, oh, this goes down right here, and we'll just approximate whatever. It's like, oh my god, right there is what is it? It's like 1/2 comma square root of 3/2. I think, probably. I could be wrong. I definitely am wrong, but you know, that's like, whoa, so sick, dude. Oh my god. And then I think like right there is like square root of 3/2 comma 1/2. I could be wrong. I could be spitting absolute nonsense right now, and I could be spitting the wrong things right there. But you know, it's like, okay, and it's like oh my god, you got the 1 and then you got like the theta right here. And it's honestly crazy how people came up with, like, just thought of this. It's like, what the heck, bro? But like, I can definitely see the vision, like how they could have thought of that. You know, it's like pretty crazy. It's like, okay, well, you know, let's use you know, SOHCAHTOA, you know, SOHCAHTOA. And then it's like, all right, well, if we go opposite hypotenuse for so, right? Opposite hypotenuse. This, yeah, we'll just call this B. We'll call this A. Oof. Okay, excuse me. That a little burp. So yeah, and then it's like A represents our, you know, like our X, and then our B represents our Y. I'm pretty sure for like the length of this side of the triangle. And then it's like, holy flip, it's B/1, and then B/1. Oh my god, that just means sine theta. Oh my god, look at that. We got no space, bro. We got no space. Oh my god. I literally like have no script for this, so I'm just like kind of doing this out of the blue. You know what? Let's drag this over here. Let's drag this guy over here. You know what? Let's say goodbye to the difference quotient. Don't need him. And you know, sine theta is equal to B, or in this case, you know, our y-axis. Crazy. It's like, oh my god. And then we do the ka part of SOHCAHTOA. You do your adjacent, which would be, you know, like get this error out of here, bro. What the heck? Who put this here, bro? What the heck? All right, get rid of this guy. And then it's like, all right, we're gonna do our adjacent to hypotenuse, which would be A/1, which, you know, just simplifies to A, right? Yeah, I can think. I have critical thinking skills. So if cosine theta equals A, that's crazy. Which that's just X, and you know, that's just Y, the y-axis and whatever. And then like your SOHCAHTOA is just B/A, which means it's sine theta over cosine. I mean, that's freaking like, bro, like that's, I don't even know. That's just crazy. I don't even know who or why they would do this, but it's pretty cool. Do I know what the unit circle is used for? Nope, I don't know what it's used for at all. I know that though, and I think I know the Pythagorean identity though. I think that's what it's called, Pythagorean identity. It's like, bam, look at that. That's sick, ain't it? I don't even know what it means, but that's sick, dude. All right, wait, am I missing an X? Is this supposed to be X's? I don't know, bro. I don't know. Either way, pretty flippin' cool, right? I don't even know who this channel is going to be for. Actually, it's mainly just for me, if anything. It's not really for anyone except me, because I just want to see my progress, literally. So, I mean, you know, kind of doesn't matter. And, you know, I was like, yo, maybe I should make a math channel or something like that. But it's like, well, I've only been doing this whole math thing for, well, let's see. It's June 2nd right now. I've been doing this ever since the end of March-ish. And so yeah, it's like 3 months-ish, right? I'm pretty sure. I'm pretty sure. But yeah, math is super cool. I used to just kind of like go through the motions in math, you know, just like, oh yeah, blah blah blah. Math wasn't really, algebra 2 wasn't really hard for me. It was just like, you know, I just got to go through the motions. I mean, it kind of got hard when we got to like rational functions. So like, oh my god, guys, it's like, how do we do this? Oh my god, it's like, oh my god, the graph goes like boing boing. It's like, holy flip, dude. Like why does it do that? And I kind of had trouble solving them. I don't even know if I know how to solve them now. But I think the graph looks like this, where there's a vertical asymptote at x equals 0. 0, yeah, x equals 0 right there, and it goes like, dong. This guy goes infinitely down, and this guy goes infinitely up. And you know what? We're just gonna say like, hey, I'm getting off track, but you know what? At this point, I kind of don't care. So like the limit as x approaches, I don't even know, like 0. Boom. Like, oh my god, it approaches 0. It can't be 0. But if we look on the graph, as it so you know, of course the limit doesn't exist, right? But we can look at like the left and right limit and stuff like that. So boom, boom, and then a lot boom. As x is approaching 0 minus, and then it's like, okay, so as x approaches 0 from the left side, you know what? Let's change the color too. Okay, so I found it, and I kind of wrote that wrong, so we're just gonna gone. And you know what? We're gonna make this a little smaller just so we got more space to write. Oh, look at that! It's so crunchy. Do h of x equals -3, and then it's like, oh my god, find the limit as x approaches 0. Let's zoom in. Let's just zoom in here. Oh my god, the limit as x approaches 0. And then it's like, and then it's like a bracket. It's like 2f of x. And then you got like the minus 12h of x. Holy flip. Let me zoom this out just a smidge. I don't want to do... Okay, never mind. It only goes in increments of 100%. It's so freaking epic. So, we got this, right? Pretty cool. Pretty cool. It looks pretty sick. So, this limit distributes into all of these, I would assume, yeah? Of course, yes, it does. So, now we have the... I don't know how I would say this, but it's like to limit as x approaches 0. I'm looking at my freaking thing real quick. F of x minus 12 limit x approaching h of x. Not that. What am I doing? 0 h of x. And then it's yeah, and then it's like, wait, am I I don't even know if I'm thinking about this correctly. Anyways, this is pretty much saying booyah. So we know this, the limit of f of x, that's just 4. So we put 2 and then we plug in our 4 minus our 12, and then we got the limit of we got the limit as x approaching 0, h of x. That is this one up here. So then we put that parentheses, and then it's like bam, 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 boom. So then this becomes 36. This becomes 8. 8 minus 36. Oh, God, I can't do that in my head. That's 28. -28, baby. Probably right. That's -28. I sure hope it is. You know what? We're pulling out the Windows calculator. So we got the 8 minus 36. Yes, it is. I don't trust myself with basic arithmetic, whatever, however you say it. I don't trust myself with that. Okay, very cool. Very, very cool. We're just gonna say goodbye to all of this. Oh, yeah, right. I remember what I was gonna talk about earlier before I got jumbled up by like the rational functions and whatever. Yeah, the rational functions. So